Woohoo! We are live. This is Math 40, Elementary Algebra. This is section 1.8, all about algebraic expressions. Woohoo! And we are finally getting into the world of algebra. Yay! So, first thing we're going to do in 1.8 is talk about how the different pieces of algebra work together. So we're not yet into equations. We won't be solving for anything. Right now, we're just going to construct things. So it's like I've just dumped a whole box of Legos out in front of you, and we're going to build stuff. So first thing we're going to do is not even build something. We're going to look at something that was already built. This is an algebraic expression, 7x squared minus x plus 6. And what I'd like to do is to just talk about how to describe the pieces. I've got some x's, I've got some numbers, I've got an exponent, I've got subtraction and addition. There's even a sneaky implicit multiplication that isn't explicitly written, but we know is there. So there's a bunch of stuff going on here. And so we want to talk about the parts. First thing I'm going to do is go ahead and make it nice and big so I've got lots of space to talk about the different pieces. Then I'm going to identify the terms and the coefficients of each term in the following expression. So a term is, I'm finding a nice, lovely, handy dandy highlighter. If we're talking about terms, then we're talking about the pieces that are separated by addition and subtraction. So I've got a piece right here, 7x squared. I've got a piece right here, and it's a little sneaky. It keeps the minus. And I've got a piece right here. So I've got 3 terms. These are my terms. That's what we call them. And if you're curious, when 2 things are multiplied together, we call those factors. So these are the terms because they're subtracted or added. Notice a couple things. The minus comes along with the x for fun. I don't write the pluses in either of these two. I could if I wanted to. It's just not generally done. And if you leave off a sign, like there's no sign here, we assume it means positive. So I've got the terms, and the question is, what is the coefficient? The coefficient, if you've never come across that word before, that's the constant in the term. Usually the constant will come first. For example, the coefficient of 7x squared is 7. I could also say positive 7. The coefficient of the opposite of x, or negative x, or minus x, negative 1. Notice that I don't write the 1 in. If I don't have a number written in, there's a 1 that we've just left off, right? Because you can do that shortcut. And then the weirdest part is that 6 is its own coefficient. So these are the coefficients. Sometimes we call that the constant coefficient. It's up to you whether you call it that or not. So that's the first thing. We can describe the terms and their coefficients, which just means the number at the beginning. Next up, I want to talk about variables, specifically declaring variables. So write an expression that represents the area of a square. So I'm going to go ahead and look at a square. Draw a picture of a square. Yay! More or less is a square. And in a square, I've got to come up with the length. Now, I'm told nothing about how big this is. So I'm going to pick a variable to represent the length of a side. And if we were in class, I'd say, what variable would you like to use? I think a lot of people would use X. I would also use the letter S for Sam, if you'd like, because of square. You know, some people choose L for length or W for width. You've got a lot of options there. Because it's a square, I can write some things. First off, I know that the corners are all square. They're right angles. They're 90 degrees. So I could write that in. The other thing I know about a square is all the sides have equal length. So I can write x as all around. So I've got my nice square. Square. If you're ever asked to do a problem that involves geometry, and you'll know that because it'll invoke geometry. It'll say square, or it'll say circle or triangle. I recommend drawing as complete a picture as you can just to get started so that you'll have a good reference. So it wants me to write the expression that represents the area. Now I know with a square, the area is the length times the width. And so A equals the length, which in a square it does not matter which is which, so x, and the width, which is also x. So A equals x squared. Now, I've done that. Yay! But what is the declaring variables part? Well, here's the thing. If you were to read my work, I think it's very clear. Capital A stands for area, and X is going to represent the length and the width. So I think someone reading this would catch on to what is going on. However, what I could do if I declare variables, I could, in addition, add what would be like if you were reading a map, the legend, or perhaps the scale for a map. It tells people, how do you read this? And I could say, and traditionally we use the word let, if you're going to be all formal. In my class, you don't have to use the word let. It's up to you. So I'm going to say let x equal the length of one side of the square. This is just a definition. Now, for me in this class, I accept, if I ask you to declare variables, I accept a verbal one, a sentence like this. It's not quite a sentence. The equals is kind of a verb, kind of a sentence. Or you could draw the picture. So I would accept the picture or the description. And I would hope that you would learn to do both, because other instructors may be a little more strict. I like visual declarations as much as verbal ones. So I'm more flexible with what I accept. So that's declaring variables. It's making sure that someone who's reading your work understands what the heck is going on. I want to point out, and this is me, see my secret agenda. I'm going to say there's a really good chart of terminology on page 70, but I'm going to let it be mysterious. Ooh, I wonder what that is. So you're going to need to go into the ebook or into your textbook and check out page 70. Ooh, that's exciting. Notice my secret agenda of getting you to look at the book. Okay, so having said that, page 70, especially if you're feeling a little rusty, because what we're going to do up next is we're going to work on some translations. So if we're going to start writing in algebra, algebra is just another language like French or Arabic or my brain is a blank. Apparently I can only think of 2 other languages. So, but I'm sure you can think of many, many more than I can. So algebra is a language, so we need to be able to translate from English into algebra or into math. So this is what this problem is about. Write each phrase as an algebraic expression. 13 more than x. So let's just start there. In fact, I'm going to use this upside down so we can really, oh, that's going to be complicated. Let me find a blank piece of paper. Just to let us really focus on the one that we're working on. So it says 13 more than x. First thing I notice, we're told what the variable is, so I don't have to declare variables. The problem is giving me the variable. And I'm going to realize that more than represents or translates into addition. Now I'm going to write this in a particular way. I'm going to write x plus 13. Now, you might notice that I could have done 13 plus x. I absolutely could, but I'm going to do the x first, and I'll show you why in the next one. 13 less than x, less than, translates as subtraction. Now, this chart on page 70 that I alluded to goes over a lot of these. So if you're like, oh my gosh, I've forgotten all of these, then go look at that, make sure you've got it so you can be referencing it. Because this is vocabulary, just like any other language, you have to practice with the vocabulary to memorize the translations. So 13 less than x only has one, well, okay, I lied a little bit, but you can only write this in one order. It is not 13 minus x. Let me get out my red pen so I can draw a line so that your brain doesn't see 13 minus x and see, oh no, that's, so if I say 13 less than x, it's x minus 13. The x has to come first. So do you see how these two go together? 13 more than x is x plus 13. 13 less than x is x minus 13. Woohoo! See? Somebody's done some thinking about this. X less than 13. Okay, less than, again, we're using subtraction. And remember that it's kind of reverse order, which, let's be honest, it's not the math that's being weird. It's the English. It's that we write things in a convoluted way. So x less than 13 means 13 minus x. We swap it, the less than swap. Okay, 13 times x. Woohoo! Well, this one's nice because times means multiplication in English and math, and it's pretty, I think it's pretty self-explanatory. So I've got 13 times x, and then I'm going to write that as 13x, and I'm going to say this is implicit multiplication. And what that means is I just take those two things and I smash them together. And if I smash two different things together, like a number and a variable, or two variables, or a number and a set of parentheses, anytime I smash things together like that, if I don't have another operation like plus or minus or whatever else could be there, then it's assumed to be multiplication. The word implicit means that it's hidden. You can't see it. Explicit means you see everything. So this would be explicit subtraction. This would be explicit addition. This would be explicit multiplication. But this is implicit because it's understood but not written. It's just shorthand. A lot of these things come down to, don't tell anyone, just between you and me, these things come down to the fact that a lot of mathematicians are actually kind of lazy. L-A-Z-Y. We're trying to write things down as quickly as we can. We're trying not to have to write a ton down. So if we can save the whole dot right there, we'll do it. We'll do it. We'll not write it in, just so that we can save that millisecond. Okay, the ratio of 13 to x. The word ratio means a couple things. It means division and it means fraction. That's what ratio. And to set up the fraction of this, the one that's mentioned first goes on top. So 13 goes on top, 2x, like that. Now, occasionally you might be doing a different kind of ratio. Sometimes you use the colon. We're not going to do a lot of that in this class. That has another setting when it's used. But that will come in the future. But for us, when we see the word ratio, we're going to go straight to the fractional form. Double x. So double means twice or 2 times. Is that clear that that's a multiplication? So double x is, you got it, 2x. Woohoo. Triple x. I know everyone wants that to be xxx, but that's something completely different in math. Triple x is 3x. 3 times x. Okay. Dun dun dun. So I love using the order of giving you simple, simple, simple. My students call this simple, simple death. So simple, 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 simple. And then finally I give you one that's like, whoa, it's all the things. So let's go through the different parts. I've got an 8 greater than, and I've also got a twice x. So remember then that the more than and less than, which greater than is just a different English word, greater than instead of more than, it's just another way of saying plus, right? So I'm not saying 8 times, I'm saying 8 greater than. So remember that we reverse the order. So when I write this out, the blue is actually going to come at the end, and the pink is going to come at the beginning, right? I'm switching the order. Greater than, less than, more than, they all switch the order. So twice x is 2x. Oops, that was exciting. And then 8 greater than plus 8. So 2x plus 8. Woohoo, woohoo. Okay, let's see what the next one is. 8 less than twice x. Again, I got 2 different things happening. I get 8 less than, and I've got twice x. So when I write it, I'm going to write the pink part first and the blue part second, because, again, the more thans and the less thans always take the problem in English and flip it around for the math. So this is twice x minus 8. Kind of woohoo? Little woohoo? Okay, I'm feeling like we're on a roll. So even though we're already at 60 minutes, I'm going to see if we can push a little further, get more of this section done. Woohoo! You guys are understanding wonderfully. Woohoo! Yay! Okay. Oh, this is what everyone loves to see. Word problems. Yay, word problems. We love them. So this says, write an expression that represents each situation. So we're moving from translation, direct translation, to actually dealing with word problems. So let's dive in. I'm told lowercase p pounds of peanuts were mixed with, I'm not sure why peanuts got capitalized. I think I was just, it was one of those days. So p pounds of peanuts were mixed with c pounds of cashews to make 100 pounds of a mixture that I can't eat. So hopefully, don't worry, I've got my Benadryl right by in case this, I know a lot of people are allergic to word problems, and word problems with nuts, it's even worse, I know. So keep the Benadryl nearby, have your support animal. I'll pull out my support Godzilla. My support, the reason that I love my Godzilla is, one, I think Godzilla turned out uncommonly well. As a non-artist, anytime I draw something that I like, it's a good day. But also, some of my fondest memories are we're watching monster movies with my dad on Saturday mornings. So that's why Godzilla is my support creature. Okay, let's dive in. We can do this. Word problems, no match for us and Godzilla. Rawr. Okay. P pounds of peanuts were mixed with C pounds of cashews to make 100 pounds of a mixture. So the first thing I'm going to do is I'm going to read that, but try not to keep reading it, because that's where you start to spiral, right? You read it, and if you just keep reading it, then you get trapped. So only let yourself read it. Decide what is a good number for you. For me, it's twice. I read it twice, and then I got to start writing something down, or I'll just, it's hopeless. So 2 times through, and then I start writing down. It could be that you read things 3 or 5 times. Figure out what that number is. So I'm looking at it and I'm asking, is there a picture I can draw? And there's probably a picture that some people could draw. I don't think I could do a good drawing of a peanut or a cashew. So I'm going to skip the drawing, but if a picture would help you, awesome. What I can do is I can do boxes, because I can draw boxes. So I can do my boxes of peanuts were mixed with cashews. So they were mixed together, and then I end up with a much bigger box, which is a mixture. So that would be my drawing, my kind of conceptualization of this problem. Peanuts and cashews put together into the mixture. So the question is, can I rewrite this in an English sentence? Can I translate this picture? Can I translate it into a sentence? And so I think about it and I'm like, okay, how about if I write peanuts plus cashews equals, and I've totally run out of room, so I'm going to write mix. Okay, so there's my drawing, which you are not required to do this. There's my sentence. Kind of notice that I'm using half English, half math. So I'm kind of blending it. It's kind of this meta sentence. And then I'm going to look back to the problem and say, what else do I know? Well, I am told that I have p pounds of peanuts. So here's my peanuts. Here's my peanuts. Okay. And I'm also told that I have c pounds of cashews. So there's my cashews. So what I can do is I can translate. I can say this is P. Now make sure you're really careful. Mathematicians are really picky about this. This is a lowercase p. I know it's not obvious, but this is, if I had lines on this paper, this would be a sitting down p, not a capital P. Plus cashews equals, so there's my peanuts, the P. And here's the cashews, the C. And then let's look for what we know about the mixture. I know I've got 100 pounds of the mixture, so that's right here. Do all my little drawings. You don't have to use highlighters. If they don't help you, skip them. So I've got 100 pounds. This is 100 pounds. And hopefully you guys all know the LBS. That is the shorthand for pounds. You can also use the pound sign if you'd like. So let's see. I've got an equation. P pounds plus C pounds is 100 pounds. And notice I don't write the units in. In mathematical equations, we don't. Now, if you go into chemistry and you write equations in chemistry, you will write the units into your equation. So it's just going to depend on whether you're doing it for math or for chemistry or sometimes physics. So I think I've got a really nice equation here. P plus C equals 100. Let me double check what were the instructions. Write an expression that represents each situation. And in fact, oh my goodness, I broke the rules. I gave you a problem. This isn't an expression. This is an equation. So it's not just an expression, it's an equation. Woohoo. Well, look at that. That's very exciting. Okay, I want to do one more, and then because I think we're getting a little bit long. Let me peek ahead there. There are 2 more word problems. So yeah, I'm going to do one more, and then we'll do a new video after this. So number 2, how many feet are there in Y yards? How many feet? So let's see, Y is the number of yards. Okay, so if I have Y yards, I need a letter to represent the number of feet. I'm going to use F. YF? Well, because I use Y for yards. Could you use X? Yes. Could you use K? Because Catherine's like the best name in the whole universe? Yes. Could you always use whatever variable is the beginning of your name? Yes, unless your name starts with an O, because it looks like 0, or an E, because that's already a something in math, or an I. That's already something in math. Plus, you can't use Greek letter pi. Pi, that's no good. But the other letters, absolutely. So I've got Y equals the number of yards, F equals the number of feet. This is declaring. I was declaring variables first because I realized I'm kind of stumped. So I don't, this one was obvious to me how to draw a picture, so I didn't have trouble with this. This one, there's just not a lot going on. And it's, part of me is saying, well, if I have 1 yard, I know that's equal to 3 feet, right? 1 yard is equal to 3 feet. And 1 yard equals 3 feet. So 2 yards equals how many feet? Yeah, 6 feet, right? Because if we take 2 of these, you'd have 3 and then another 3. So, and then 3 yards would be how many feet? 9 feet. So what if I had y yards? How many feet is that? So that's the question. Notice I didn't draw a picture. This time I just started writing stuff down. This is what makes word problems, I think, fundamentally scary. So let's bring Godzilla back in. Godzilla's here to tell you it's all okay. Plus, maybe smashing, some cities might make you feel better. What's hard about this is that this word problem has a completely different solution than this one. But let's come back to this. Did I give you guys enough time? I was stalling. You notice that? Yeah. Okay, so 1 goes to 3, 2 goes to 6, 3 goes to 9. What are we doing each time? We're multiplying by 3. So how about 3y feet in y yards? So 3 times as many feet as in yards. Notice something interesting. I set up I declared variables. Did I even use the f? No, I didn't even have to. So there are 3y feet in y yards. Now, for me, you don't have to write the equation. You could write the whole, sorry, not the equation, the sentence. You could write this expression and just turn that in, or you could write it as a sentence in English. I accept both. Some teachers are going to say, no, you need the sentence. So it just depends on the setting. So you guys, we did it. We did it. Woohoo. Okay, there'll be one more video for those last 2 word problems. So I'll see you guys in the very next video. Math on. You guys are awesome. You did it. Woohoo!